So today is May 12th, the day after our last test for some of you. Others, you might have the final. But for those of you that don't know the final, congratulations. Or if you plan to exempt and you're not going to take the final, once again, congratulations. We are still graphing logs and their inverses. So that's what we will be working on again with today. Okay, so 1 through 4 tells us, it says, find the domain of each function. Remember that the argument of the log must be greater than 0, and then when finding the domain, the base is not necessary. It doesn't really affect anything. So let's try number 2. So ln, remember it's natural log. This does have base e, so this is the same as log base e of 2x plus 3. Now it says that our argument must be greater than 0. So first I want to know what makes this 0. So I'm going to say 2x plus 3 does not equal 0. I know I don't want to be that number, and we're just going to solve this real quick. Minus 3 minus 3, 2x equals negative 3, and then divide by 2, divide by 2. So I know x cannot be negative 3/2, but I can be something that is smaller than 3/2, or it could be something that is greater than 3/2. So I'm going to pick one number smaller than negative 3/2, and one number greater than negative 3/2. Plug it into my x and see if it gives me a negative number or a positive number. So let's say 2 times negative 2 plus 3. So this is negative 4 plus 3, which is negative 1. So we cannot take log of negative numbers, so I know I can't use these values. What about if we are bigger than negative 3 over 2? So 0 is bigger than negative 3 over 2. 2 times 0 is 0, and 0 plus 3 is 3. This is a positive number, which means it does work. And you can write your answer with the inequality, so x is everything greater than negative 3 over 2. Or you can write it in interval notation and say, negative 3 over 2. So negative 3 over 2 to positive infinity, everything greater than negative 3 over 2. Both of these are correct answers. You can use either notation. So let's look at number 4. So 4 gives us a hint. It says, hint, solve x squared minus 8x plus 15 is greater than 0 by factoring. So we want to factor our argument this time. Well, if I'm factoring, I need two numbers that multiply to get us 15 and add to get us negative 8. So that would be x minus 3, x minus 5, greater than 0. And I know that I have to be greater than 0 for my argument, which means I don't want to be either of these solutions. X minus 3 does not equal 0. And x minus 5 does not equal 0, just like the last one. So if we solve both of these real quick, so I'm going to add 3 to both sides, add 5 to both sides, we see that x cannot be 3 and it cannot be 5. But I know I can be something less than 3. We can be in between 3 and 5. And we can be something greater than 5. So this time we have 3 things to check. So a number less than 3 is 0. 0 squared minus 8 times 0 plus 15. Well, 0 squared is 0. Negative 8 times 0 is 0. And 15 is a positive number. So I know that this one works. The only number in between 3 and 5 that's easy to plug in would be 4. 4 squared minus 8 times 4 plus 15. 16 minus 32 plus 15. Well, 16 minus 32 is negative 16, and negative 16 plus 15 is negative 1. So we can't use this one. It gives us a negative number, and we cannot take the log of a negative. And now if we are greater than 5, 6 squared minus 8 times 6 plus 15. That's 36 minus 48 plus 15. 36 minus 48 is negative 12. And negative 12 plus 15 is positive 3. So once again, positive number, which means it does work. So we have 2 places where this works. And I can use these 2 inequality notations, or I can write one interval notation and say this is negative infinity to 3 union 5 to infinity. So everything smaller than 3, everything bigger than 5. So that's for finding domain. We've also been working on graphing our inverses. So in here we kind of have a 3-step checklist. Step 1 says, determine the inverse of the function, and it gives us a hint that when we solve it, it should be an exponential. So if you don't get an exponential function, go back and check what you did wrong. So first thing I'm going to do is I'm going to say y equals log base 3 of x minus 1. And then for inverses, I'm going to switch x and y. So x equals log base 3 of y minus 1. From here we can convert to exponential. My base stays my base, and x and y minus 1 switch places. So x stays with the 3 this time, and this equals y minus 1. And now we just want to get y by itself, so we add 1 to both sides. 3 to the x plus 1 equals y, and this is our inverse function. So that takes care of step 1. Step 2 says make an XY table and graph the inverse. So we'll make an XY table. It's just a table of values for F inverse. And I'm going to use 0, 1, and 2. So I'm just going to plug all 3 of these numbers into our function to see what we get. So 3 to the 0 plus 1. Anything to the 0 power is 1, so this is 1 plus 1, which is 2. 3 to the 1 plus 1, which is just 3 plus 1, which is 4. And 3 squared plus 1, which is 9 plus 1, so 10. So here's 3 points that I have. I have 0, 2, 1, 4, and 2, 10. Now it says we want to include the horizontal asymptote. So to find our horizontal asymptote, we've usually just been taking the h that's inside of our set of parentheses. For a log or for exponentials, it is our k. So this one has an asymptote of y equals 1, which would be this line right here. And then we'll just finish graphing. So now I've done step 1 and step 2. Step 3 says pick key points on the graph, switch the coordinates, and plot the new points. Okay, so this is going to get us f of x. So I'm going to take my points that I got for f inverse and switch them. So 0, 2 becomes 2, 0. 1, 4 becomes 4, 1, and 2, 10 becomes 10, 2. And I'm going to come over here and plot these as well. So we have 2, 0, 4, 1, and 10, 2. In order to get the vertical asymptote, we are going to take our h value. In some cases, you can't just take the h. What's actually happening is we are taking our argument, setting it equal to 0, and that's what's giving us the vertical asymptote. So we say x minus 1 equals 0, and if we add 1 to both sides, x equals 1, there's the equation for our horizontal asymptote, which would be this line right here. And then we can finish graphing. So it says, think about the relationship between the asymptotes. Well, if we look, our two asymptotes, we have x equals 1 and y equals 1. So it looks like our inverse, we switch x and y, just like with our points. And I'm just going to label these real quick. So this is f of x, and this one's f inverse. Now, if you didn't catch on to graphing the first time, don't worry, we have one more example of graphing. And we do the same thing, so same steps. We want the inverse first. So this is y equals, remember that ln is the same as log base e. Switch x and y. Now we're going to convert to exponential, so our new base is e. We get e to the x equals 2y minus 5. We want to get y by itself, so we add 5 to both sides. E to the x plus 5 equals 2y, and then finally to get y by itself, divide both sides by 2. So inverse says e to the x plus 5 over 2. I can also rewrite this as two fractions with a common denominator, e to the x over 2 plus 5 over 2. And this just makes it easier to see what k is. So now I'm going to make my xy table. I'm going to use 0, 1, and 2 again. And do the same thing. I'm going to plug them into my inverse function and see what I get. E to the 0 plus 5 over 2 equals e to the 0 is 1 plus 5 is 6. 6 divided by 2 is 3. Now e to the 1 plus 5 over 2. If I type this into a calculator, it's going to tell me that e to the 1 plus 5 over 2 is equal to 3.86. I am rounding a bit. And then last one, e squared plus 5 over 2. This is going to give us 6.19. So here's some points for the graph. So 0, 3. 1, 3.86. And 2, 6.19. For exponentials, our asymptote is y equals k, so the asymptote for this one is y equals 5 over 2, which is 2.5. So somewhere in between 2 and 3. I got a bit skewed. And then we'll finish graphing. So this is f inverse. Now in order to get f of x, I switch my points. So 0, 3 becomes 3, 0, 1, 3, 0.86 becomes 3.861, and 2, 6, 1.9 becomes 6.192. So I have a 0.30, 3.861, and 6.192. In order to find the vertical asymptote, we're going to take our argument and set it equal to 0. And if we solve this by adding 5 to both sides and then dividing by 2, we get that x equals 5/2, which we know is 2.5. So once again, when it comes to the asymptotes, it looks like we did switch x and y for vertical and horizontal. So this would be f of x. So this is our graph. We're done with this one. Below there is a note for log functions on the calculator that says you have to change the base. With your TI Inspires, you do not have to change the base. You can actually plug it in with the correct base. It does ask us to go back and look at 1 and 2 and graph the originals and inverse in our calculator to see where they're accurate. So we're going to do that real quick, and that'll be the last thing that we do. So I'm going to open my calculator, open a graph, and it looks like our first function was ln of 2x minus 5. Enter. So this was our parent function, the original one. It's not parent, but our original function, f of x. And then I want to add a new one, so I'm going to hit menu, and then 3, 1. The other one, our inverse that we found, was so e to the x plus 5 all over 2. So here's our two functions. Here's the top one is the e to the x plus 5/2. That was our inverse. So here's what my graph looks like on here, and then back on our paper, it looks pretty much the same. Our inverse and our original function. It says also on our calculator to add in the graph of y equals x. So let's see what happens if we do that. So I'm just going to say equals x. So here's that line y equals x. And it says, what do you notice about the relationship of this line to the other graphs? Well, if I look, I'm mirroring across the line y equals x. My graphs are mirroring one another across that line of y equals x. And so that's what's happening. So that is it for the notes. Make sure, so you do have an assignment, the last 3 pages, right? And it's just asking for what we went over in the notes. It's asking for you to find inverses, the graph, key points, things like that. Make sure to put your name on every sheet of paper that you turn in and turn it into Canvas in order to get your grade.